Intro to functions. The vertical line test is the first thing you have to know for today. And it is what it says. You draw a vertical line through a graph. If you touch two or more spots in the same graph, then it is not a function. And here is the actual test in action. So I have a graph here, and I'm going to draw a vertical line here. How many places did it cross that graph? 1. What about here? How many places? Is there any place that I can draw a vertical line where it will touch more than one spot on the graph? No. So the answer is yes, this is a function. How about this one? If I draw a vertical line here, how many places am I touching? 2. So this one is no. It is not a function. What about this one? How many places? 1. What about here? And this curves out continuously like this. So I'll draw it a little more pronounced. So no matter where you draw a line, it only crosses once. The answer is yes, it is a function. What about this one? Is it a function or not? It is, yes. So the answer is yes. What about this one? No. At least 2 spots where you're crossing, so the answer is no. No. This is not a function because it crosses in 2 spots. That is right. Next one goes to 11C. Is that a function or not? It is a function, yes. When you draw a vertical line, it's only going to go through 1 spot, like that. And then 11's W. Is this a function, yes or no? Yes. The answer is yes. Draw a vertical line, only crosses in 1 spot. What about this one, Chavaria? No, because I can go there, 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 and there. So the answer is no. Alright, state whether each relation represents a function. There's a specific rule you have to remember for this. It works whether it's in a point form or if it's in a table form. You have to determine yes or no if this is a function. The way you do that is look at the first numbers in each pairing. You have a 0, 3, and -5. Do any of those repeat? We just have 1 0, 1 3, 1 -5 in the X spot. If that is the case, and you have no repetitions, then you can automatically say that yes, this could be a function. On this one, do we have any repetitions in the X values? What repeats? -1. So if you have a repetition, then go look at the numbers beside it. Are these the same thing? No. So if you have X values that point to 2 different Y values, then it is not a function. You cannot plug in a -1 one time and get a 2, and then plug in a -1 into the same function and then get back a 3. That's not supposed to work that way. That is why some of these items that we had before, such as this one, were not a function, because you could plug in a +2 and get something here and yet still get something down here. That's why we have the vertical line test. So this one would be no. Fields. Would this be a function, yes or no? Yes, it would be. We have a 0, 2, and a 5. No repetitions in the X values. Horner, would this be a function? Yes. We have -8, -6, -4. And the next one goes to Ison. Would this be a function? Yes, because we have -7, 4, and 7. So that one is definitely yes. And on this one it goes to Karshner, -9, 1, and 1. The answer would be no. Next one goes to Lujan. Is this the function or not?
No.
It is no. We have a -2 pointing to a 2 and a -2 pointing to a 1. That cannot happen. This one goes to McAllister. A function, yes or no?
Yeah.
Yes, it is. All we have is 4, 5, and 6. And this one goes to Moore. Is that a function, yes or no?
Yes.
Yes, it is. We have 0, -2, and 2. On this one goes to music. Is that a function, yes or no?
No.
No, it is not. -6 and 6 with those 5s. Alright, here are some examples of another type. Evaluate the given function for the given values of x. Here is the function. You have to plug in each one of these to come up with a y value. So you just start as it is. You start with f of 12. And if I put f of 12 into 3/4 x minus 2, I put the 12 in where the x is at. 3 times 12 is 36, divided by 4 is 9, minus 2 is 7. So I've put a 12 in, and I came back with a 7. It generates an ordered pair. 12 and 7. Now I have to put in 16, so I'll go back through and put in f of 16 and get 3/4 times 16 minus 2. And 3 times 16 is 48, divided by 4 is 12, minus 2 is 10. So I put in a 16 and I came back with a 10. And the last one is 20. F of 20, that's going to be 3/4 times 20 and then minus 2. 60 divided by 4 is 15. Minus 2 is 13. I put in a 20 and I got back a 13. 7, 10, and 13 is what is generated from 12, 16, and 20. 1/2 times 8 minus 6. Half of 8 is 4, minus 6 is -2. And then for f of 10, that's going to be 1/2 times 10 minus 6. Half of 10 is 5. 5 minus 6 is a -1. If you came out with -4, -2, and -1 for your result, then come on up. Okay, if the domain of f of x equals 3x minus 2 is integer values such that -2 is less than or equal to x and x is less than or equal to 1, find the range. That's the exact same thing that we just did. The wording is different. So we'll explain the wording. If you generate an ordered pair such as 2, 4, this is given to you. That's the domain. What comes out is the range. So the domain of that function is going to be from -2 to +1. Negative, and they have to be integers. So -2, -1, 0, and 1 is what this is telling you. And it says find the range. That means you have to input each of these to come out with a y value in each case. That's no different than what we just did. So we're not going to spend practice time doing another one. Use a graphing calculator to graph the function and state the domain and the range. So to graph this function on your graphing calculator, you would have to go to y equals and clear anything out that might be in there. So that's what y equals looks like up there, and I put in a negative 4x. Once you type in the negative 4x, you're going to have to go to your window to make certain that what you graph is going to show up properly. If you hit zoom 9, it may not give you everything you need to see. The window button should be the second one from the left under the calculator screen. And if you hit that, it'll give you the ranges in there for your window. You want to make sure that your x min, usually about negative 10, and x max 10. Y min, negative 10, Y max 10. Should be a scale in there as well. We just usually leave that at 1. Once you make certain the window is adjusted properly, then you can hit graph and the graph will show up. That's the graph. Did you put in a negative 4x? Are there any limitations, or is there anything excluded as to what x could be? This is the x-axis. Can I put a negative 10 in this function? Can I put a 5 in? If I go over here to 5, will I at some point intersect that graph? This graph goes on forever, so there is nothing that can be done to change that. So your domain is represented by x. So the domain could be all real numbers. Now the range is y. That goes up and down. Is there any limit to y? Will this keep going upwards? Will the graph keep going upwards? Yes or no? Yes, it will. Will it keep going downward like this? Yes, so all real numbers for the domain and the range of this one. On this problem, here are your x's. Remember, the x is the domain. So, does this keep going? Does this graph keep going to the right and to the left, keep spreading out? Yeah, so are there any restrictions on x? No, so x could be all real numbers. Now, what about the range, the y? Up and down? And any limitations on y? It doesn't go past what number? 0. So that means that the range would have to be such that y is greater than or equal to 0. Nothing less than 0 shows up on your graph, so it's not going to be coming out of the function.